The rise of the machines is inevitable. We're not talking science fiction, nor crude tools such as your sat-nav, but our acceleration towards building a true artificial intelligence capable not just of computer heavy lifting, but of creativity, of imagination, and maybe even consciousness. This is a field that attracts some of the finest minds on Earth, and some of the biggest business too. Neuroscientist, chess master, world champion gamer Demis Hassabis founded an AI company, DeepMind, in 2011, which was acquired by Google earlier this year for £400 million. This week, he won the Royal Society's Mullard Award, which recognises individuals whose work in the sciences is likely to contribute to national prosperity. Demis, welcome and huge congratulations. That it really is quite something, but also rather a lot of pressure on you there.
So yeah, I mean, it is quite a lot of pressure, but it's good kind of pressure in that this is sort of pressure that I love, and I've always been fascinated by intelligence and artificial intelligence since I was a young kid, and I think the reason is that I always felt that if we could crack intelligence, then we would be able to use that technology to help us as a society solve all the other things that we wanted to master.
Now, tell us about what DeepMind is focused on, and also why it might contribute to Google's ever-expanding set of services.
At DeepMind, we're trying to build what we call general learning algorithms. And there's two key aspects to that. So it's the fact that these algorithms learn directly from experiences how to do things, so they're not pre-programmed. And then secondly, we're interested in this idea of generality. So the idea that one system or one set of algorithms out of the box can do multiple tasks without any retraining or reprogramming. So this is what we regard as sort of true AI. And, it's a kind of new type of approach to AI.
See, that does sound like the same type of intelligence that humans have, in that once you start to do one thing, you can immediately transfer that ability to something else. And does that exist in computers yet? I mean, where are we at?
So that's a very prescient sort of comment, is that transfer learning, that's called, this ability that's sort of unique to humans in a way, that we can, transfer some knowledge we have in one domain and immediately apply that usefully in some totally new domain that looks completely different maybe, but has the same underlying structure. And at the moment in computer science, we don't know how to build those types of algorithms. But that's exactly the sorts of things that we're trying to make breakthroughs on at DeepMind.
So let's briefly talk about chess. You're an expert chess player, I believe. Not quite grandmaster, you're a master. Yeah, well, that's still pretty good. But we've been beating grandmasters at chess since 1997, when Deep Blue, IBM's Deep Blue, beat Garry Kasparov, right? Now, is that AI or not? It seems that this is a computer capable of incredibly complex tasks.
Yeah, so that's a really interesting example of a form of artificial intelligence, but I don't think it was really what I would call intelligent, and you can see that by the fact that it wasn't able to do anything else at all. Not only really different things like, say, drive a car or something completely different, but even things that are strictly simpler. So, for example, being able to play noughts and crosses, which any human chess master or grandmaster, you'd be able to trivially teach them how to play noughts and crosses, even if they'd never come across it before, and they would be expert at that immediately. And yet this machine would have to be reprogrammed totally from scratch to play even as simple a game as that.
Okay, now when we discuss AI, when we talk about machine learning, often we come across a handful of thought experiments which are very useful in trying to unpack and trying to explore the difference between machine intelligence and human intelligence, and whether those two things can genuinely be bridged. And the first and the most obvious is the Turing test, which goes roughly like this. Alan Turing, who you can see at your cinemas in The Imitation Game as Benedict Cumberbatch at the moment, he invented this in the 50s. You have a human player asking questions of either another person or a computer, which they cannot see, and they don't know which is which. If the human player can't determine whether his or her opponent is a computer rather than a human, then the computer has passed the Turing test. Now, how does this relate to artificial intelligence and machine intelligence?
So just before I answer that, I think I should say Alan Turing is one of my all-time sort of scientific heroes. But the Turing test itself is actually not a very good test for real AI. And the reason is that, it's very easy to fool non-expert judges into thinking they're talking to a human rather than a machine in the 5-minute time window they have. And it ends up becoming a bit of a parlor trick rather than a real test of intelligence.
So Turing test,
important culturally, but possibly not that significant for artificial intelligence research itself. So, Demis, what would be the test that you would need to satisfy yourself to create true, strong AI?
So, we define intelligence at DeepMind as the ability to perform well across a wide range of environments. So I think any good test will have a range of tasks, quite diverse tasks that the same system would have to get good at, including some tasks that it had never seen before and would just have to deal with on the spot.
Can you give me some examples of how that would work practically?
Yeah, so we at DeepMind, we actually use game environments as a test bed for the intelligence of our algorithms. And the reason we do that is because there are thousands of games programmed out there, so we can utilize all this work that games coders have done. And there are thousands of games, so our single system can't possibly know how to play beforehand all these different games. It's got to learn directly from the pixels on the screen. And so that's what we did actually last year was create an algorithm that could play classic Atari games from the 80s just from pixels on the screen and being connected to the joystick and being told to maximize the score and nothing else. So we think that's a better test of intelligence than something specific like just playing chess well or even passing the Turing test.
Okay, so one of the ways you're looking at these is from a gaming environment, which is great for people like us who play video games. But what about for the general population who aren't interested in gaming?
So then moving forwards, and this is something I would love to see, this is why I'm trying to build AI, is if we think about how, let's say, science, I'm very interested in the idea of creating AI scientists to assist human science or AI-assisted science. And what I mean by that is having algorithms that can actually find insights in raw scientific data that maybe even human scientists didn't find. I think that would be, if you want a kind of single test of intelligence, I think the day that an algorithm comes up with a scientific breakthrough that is published in Nature or Science that it mostly came up with would be, I think that would be a very poignant demonstration of intelligence. When you can start showing machines that are creating new solutions to things that are useful for us, like a cure for a disease or something like that, I think that's, we're starting to get to unequivocal sort of tests of intelligence, I would say.
Demis Hassabis, founder of Google DeepMind. Now,